So we're going to look at how bubble sort works. So what we're aiming to do is sort an array of data. So we've got a series of numbers, and what we want is to get them in order, into an ascending order. Okay, so my set of volunteers here are going to be the array. Each one is in a separate position and each one has a piece of data. So take this number and hold it so that people can't see it. So we filled our array with numbers, and each position in the array is labelled by a number itself that is its position. But with arrays we do it in a slightly different way to the way normal people count, because we count from 0. So you're in position 0, you're in position 1, you're in position 2, position 3 and position 4 of the array. So what we're going to do is try and get these numbers into sorted order. Now with a small number like this, as a human you could probably look at the numbers and immediately be able to say, oh, that one goes there, that one goes there. But what you're actually doing in doing that is very quickly kind of comparing pairs of numbers. In a computer it can't just look at everything, it can only look at pairs at a time. And so that's what we're going to have to do. We need an algorithm that can look at pairs of numbers and decide if they're in the right order or the wrong order, move them around, and hopefully by doing that over and over again we end up with them all in sorted order. And even for a human, if you had more than 5 or 6 pieces of data, if you had hundreds, thousands of pieces of data, you wouldn't be able to do it just by looking at them. So that's what we're going to do. Now, what we can do is a single comparison. So a computer has comparison commands. You can compare one number to see if it's equal to another one, if it's greater than another or less than another. So we'll do comparisons of whether one number is greater than another. That means we can basically look at 2 things at once. So I could kind of look at these 2 numbers, so if you turn those 2 round, and I can make a decision about those 2 numbers and what I want to do with them. So what I'm going to do, I need to do that over and over again, hopefully enough times with different pieces of data until eventually they're in the right position by making a decision, oh, they're in the wrong order. And what I'll do is I'll just swap them over if they're in the wrong order. If we're looking at 2 numbers and if this one is greater than that one so that they're in the wrong order, then we swap them over. If this one's not greater than that one, then we leave them alone. That's an if statement with a simple test if one value is greater than the other. Okay, so we'll do that over and over again. And to do it in an organised way, what I'll do is I'll just start at one end of the array and work my way through a position at a time, comparing pairs and swapping them over. So if you turn those back for a moment, so we start with just an array where we don't know what anything is, and I will act as a pointer. I'm going to go from one end of the loop of the array to the other. So I point at a particular person, and what I'm actually interested in is the pair, so I'm really pointing at that person and the one next to them. So if I point to the person here and the 2 of you then show your numbers, we make that test. Is this one greater than that one? No, it's not, so we leave them in the right order. They're already there, and so you then turn the values back and hide them again. And then what I do is I move on to the next position. And I'm pointing at this position, so I'm going to look at that entry and the entry next to it. So we turn them over and see those 2 positions, do that comparison, and this time this number is greater than that number. They're in the wrong order, so I need to swap them over. So I swap the 2 pieces of data over, and now they're in the right order, and then I move on to the next position. So hide the 2 values again. I then move to the next position, and I'm now pointing at you, and so it's the next 2 people, the next 2 positions in the array we look at. So let's see your 2 values, we compare them again. This one is greater than that one, so we swap positions. Okay, and then they're in the right order, so we cover them up again, and then I move on again and we look at the 2 values. So I'm pointing here, so it's you and the next one we show, and 30 is greater than 12, so they're in the wrong order, so we swap you 2 over. And at this point there's no point me going any further because there's nothing to compare him with, so hide your 2 values again. So what I've just done is a single pass over the array. So there's two things now. What have I done in programming terms? I've just done a loop, a for loop actually, that runs from one end of the array to the other. It's a for loop that starts from position 0 and counts through the positions until it gets to the end of the array. And it's not quite the end of the array because I stopped one position early. So if the array has 5 values in it, it's an array of length 5, then what I've done is counted through 4 positions, and I'm counting from 0, so I've actually counted from position 0 up to position 3, 0, 1, 2, 3, and then I stopped. So in programming terms, it's a for loop that counts from 0 up to 3. Okay, so what I've done is essentially one pass of the array. The question then is the array now in sorted order? Having done that, well, the answer is no, it's not. So we've got some values that are really small that are still down that end. Just doing that isn't enough because we haven't compared everything with everything else. So we need to keep going. But what I've just done is one pass. And so I need to do multiple passes to do that. So I need some way of counting. I'm acting as a counter to keep track of what position in the loop I am. I'm a sort of a pointer. I would be a variable I that's being counted in the for loop. So that's what I'm now going to use you for. You're going to keep track of how many passes I've done. So I just did the first pass and I'm going to count passes from 0 again. So you're starting with number 0, and then when I get to the end of the pass, we add 1 to the number you're remembering, and pass has now become 1. Okay, so you were 0, I've just got to the end of the array, I've compared it once, and now you change to 1. Okay, so I then go back to the beginning and I do it all again. Okay, so I point to the first one, and that means the first 2 values turn around and we look if they're in the right order, and it turns out they are in the right order, so far so good. So we hide them again and I move on to the next one. Are you 2 in the right order? Let's compare the 2. So they're in the wrong order, so we swap them over. Okay, so they're fine now. Hide them again and I move on and we look at the next 2. And they're in the wrong order, so we swap them over and then hide the values again and move on to do another comparison. And again I stop when I get to the end, but let's compare the last 2. They're in the right order now, so I can leave those alone, and I've finished that pass and I go back to the start again. So the question now is that enough to have sorted them? I've done 2 passes, he's counted up 0 to 1. Is that enough? And the answer is no. So how many passes do I need? Well, in this case, it turns out I actually need 4 passes. And we'll see why a little later, but you need 1 less pass than the amount of data. If I've got 5 pieces of data in my array, I need 4 passes to sort them. If I had 100 pieces of data, I'd need 99 passes to sort them. If I had 1,000 pieces of data, I'd need 999 to guarantee they're in sorted order. They could end up being sorted before that point, but to guarantee whatever order they started off with, I'd need to do 1 less pass. Okay, so I'm going to have to do it again. So we add 1 to pass. Pass is now 2, and we start from the beginning again. We compare those 2. They're in the wrong order, so we swap them over, hide them again, and do another pair of comparisons. So let's see your 2 values. They're in the wrong order, so we swap them over and hide the values again, and we move on and compare the next 2. And they're in the right order, so we can leave them, and then we move on to the next ones and compare those, and they're in the right order, so we can leave them. Okay, so turn those back, and I've now done how many passes? You're up to your 3rd passes, so you've counted 0, 1, 2, and actually to be guaranteed that they're in the right order, I need to do 1 more pass. It might be that they sorted earlier than that, but I need to do one more pass to be absolutely certain. So we'll do this again. So I look at those 2 and actually they're in the right order, and I move on and look at the next 2 and they're in the right order, and I move on and I look at the next 2 and they're in the right order, and I move on and I look at the next 2. And it turns out on this particular occasion they were in sorted order already, but what I know now, guaranteed by doing that, they're in sorted order. So let's turn them all over and see what they all are. and 3, 12, 16, 21, 30, I've sorted them. Okay? And I might have needed that last pass. It depends on the order the data was to start off with. Of course, you could be given data that just by chance happens to be in the right order to begin with, and then you'll be doing lots of work to compare them and never actually have to swap anything. But you don't know that that's the situation you're in at the start. So to guarantee that data is sorted using bubble sort, which is the algorithm we're looking at, you have to go over them again one less time than the amount of data.